Hello everyone. In this video, I have described resonance effect. Again, I have described different rules for writing resonance, and I have described various applications of resonance, that is in deciding basic strengths of aromatic amines and comparing it with aliphatic amine. Again, nature of acids, acidic strength can be well understood. In addition to inductive effect, resonance effect is helpful, and same we will discuss in coming slides. So as far as the resonance is concerned, when we talk about the resonance, in most of the students' mind, aromatic ring comes in a picture, but they start thinking about the aromatic amines. But try and understand, resonance is not operative only in benzene. Rather, there are many compounds where resonance is operative, or many compounds which exhibit the phenomena of resonance. So literally, resonance is, in simple language, it is delocalization of electrons. So D means change, localization means location. So electrons change their location from one place to another within the same molecule. This is important. Now which electron? Not all. Only pi and lone pair of electrons. Again, not all the types of pi electrons and lone pair of electrons in given compound will undergo delocalization. It depends upon the structure. But as in beginning, we can say that resonance involved delocalization of pi and lone pair of electrons. Now what this phenomena is, intentionally I have taken this structure for the discussion, because if I take benzene again, it fixes in the minds of student that resonance phenomena or resonance effect is operate, or it is there only in aromatic ring and not in other compound. So it is a simple molecule ozone. We can draw more than one possible structure for ozone. Now what is the case? There are three oxygen. The middle one, it is electron deficient, so positive charge is there. The one which is there at another end, right hand side, it is rich in electron. It contains excess electron, so it is again unstable. Now these two are unstable, reasons are different. One is electron rich, another one is electron deficient. So this oxygen will share its electron with the neighbor one, so that it will itself become stabilized and it accept because it is unstable. Now while doing so, these pi electrons will become migrated to the another oxygen. So this is how. This is the one which is rich in electrons, so it is sharing its electron to the positively charged oxygen. Now this this is the one which is reason why double bond will appear over here, and as a consequence of that, this double bond will broken down, pi electron will become migrated on the another oxygen. So now thing is that if you compare these two structure, only position of electron is changed, but position of atoms does not change, and it is possible we can draw more than one possible Lewis structure for these two. Now these two are interconvertible between one another, so this structure gets converted to this and vice versa. So both are interconvertible, so that's why we have to show them by using double-headed arrow. So resonance always indicated by double-headed arrow. So sometimes I will read bookish definition. More than one Lewis structure can be sketched for the molecule, especially when it contains the multiple bonds. And intermediate between such two or more structure is called as the resonance form or canonical form. So this is the one we can say it is a hybrid of two. Better way we can represent in this manner. So dotted line indicates what? Delocalization of electron from one oxygen to another via this oxygen. Such molecules are called as the resonance hybrid. So individual one particular structure will be called as hybrid, and this is a resonating structure. This is also a hybrid. Resonance occurs in multiple bonds due to delocalization of pi and lone pair of electrons. Now these are called as a contributors or hybrids. Better way we can show carboxylate ion in this manner. We already discussed this when we were talking about in the video where we will learn about the inductive effect. So delocalization of electron occur from one oxygen to another oxygen of carboxylate ion via this carbon. Now this is another example where resonance is operative. Intentionally I have taken examples which are different from aromatic ring, so that I just want to make the things clear. It is not a phenomena which occurs in benzene only. I am repeating this again and again. So this oxygen, again I will explain it why this will undergo resonance. This is the one which is rich in electron. It will coordinate its electron to the nearby nitrogen, and as a consequence of that, oxygen is more electronegative than nitrogen. So pi electron will migrate over the oxygen. So we will be able to draw its another form. Now particularly this oxygen becomes stable, but not the other one which was stable earlier. It has become unstable, so it will share its electron back to the nitrogen, and this double bond will be broken down, and we will get a structure which was there earlier. So that's why I made mention resonating forms are interconvertible. Now we'll see rules for writing resonance. Some rules are already made mention. All contributing structure must have the same number of electron pairs, and all forms are proper Lewis structure. So thing is that whatever contributing forms we do sketch must have same number of electron pairs. If you draw a resonating form for particular structure, and we have to count the electron pairs between both the forms, and if electron pairs are same in both, then only we can say they are correct resonating forms of one another. So this is rule of thumb, number of electron pairs must be same among the two, and we should not do any mistake in sketching the structure. Both the or all the hybrid must be a proper Lewis structure. All contributing structure must have the same number of electron pair, already discussed. Only position of electron will change, but position of atom will never change. This is a very important rule. Position of electron will change. We already discussed in the beginning. Resonance is nothing but delocalization of electron, not atoms. So position of atom will remain same. Again I am repeating, position of not all the electrons, only depending upon structure, only pi and n electron will change. So that is what the next rule is. Only pi electrons or lone pair of electron will become delocalized. Structure in which all atom have a complete octet and negative charge is on electronegative atom is more stable and make larger contribution to the hybrid. So this is all about the contribution to the hybrid. All contributing structure must have same number of electron pairs. All are proper Lewis structure. Only position of electron will change, but not position of atoms. I am explaining this rule with the help of particular example. So now you consider this example. This is a generalized structure where I have written substituting in the generalized form R1 and R2. So here resonance, reason for resonance is this carbonyl carbon. This carbonyl carbon, which is electron deficient due to the oxygen, as a consequence of that it is in search of electron. So pi electron will become migrated over here. Now when pi electron become migrated, the carbon CH, this one particularly, will become electron deficient, and it is when become deficient it accept electron pair which was there on the nitrogen earlier in the form of a lone pair. If lone pair of electron is not available over here, migration of this pi electron is never possible. So this delocalization is supported by lone pair of electron present on the nitrogen. So this is how sequence is there. First pi electron will become migrated, then pi electron of olefin will become migrated over here, so that new double bond will appear between the carbonyl carbon and CH, and due to migration of lone pair of electron which is there on the nitrogen, a double bond will appear between nitrogen and CH. So this is the resonating form. Again you will observe here oxygen is not stable, negative charge, nitrogen is not stable, positive charge. So when this nitrogen is not stable, it will indicate positive charge, indicate instability. So it will take pi electrons on it back, so that lone pair of electron will be there, nitrogen becomes stable. Now due to this migration of pi electrons, this carbon become unstable. So carbocation which is formed will allow or will pull pi electron from the olefin, so that a double bond will regain here, and carbonyl carbon, which is now positive, full positive charge will be there. So oxygen will share its electron to the carbonyl to the carbocation, so that a carbonyl bond will again appear. So this is, in this manner, these two forms are interconvertible, and that's why they do follow the phenomena of resonance. It is denoted by two-headed arrow between the two contributing structure. Arrow does not show the process of interconversion. This is important. Structure in which all the atom have a complete octet and negative charge is electronegative atom and is more stable and make larger contribution to the hybrid. Now I will discuss resonance in the benzene. Here delocalization of electrons will occur, and like you know, it is a continuous delocalization will occur, and that's why benzene we can show in this manner with the help of this is a KQL structure rather. Dotted arrow indicates delocalization of electron. So real structure of benzene is a hybrid structure of A and B. So this is what contributing structure. This is contributing structure where alternate double bonds are the one which has in which their location has been become changed. Now this is a hybrid. Hence hybrid structure is represented by the inserting a circle or dotted circle in a hexagon C and D. So both, either we can show benzene with the help of form C or form D, one and same, both are correct. Circle represents 6 electrons which are delocalized over 6 carbon atoms. As their positions are not fixed, we can denote them by using the circles, either full circle or dotted circle. Thank you very much for watching my video patiently. If you want to learn chemistry in simplified manner, do subscribe my channel, share my videos with your friend and stay tuned.